Hello? Yes? Oh, okay. Good deal. Everybody here okay? A little louder? Okay, how about some RFID technology? Well, that fine substitution for man and the horse in the rain. Man in the horse. Okay, so I am Morgellon, the lowtek mystic.
Are they ready to go?
Are we ready to go? We're ready to go. Good deal. To my left is knightl0rd, and we are here today to talk about more RFID technology because it is goodness and it's fun and it's going to be around for a long time. So we need to be able to have a little bit of power to this. So, and that the ability to at least know what's on our data and our stuff that we've purchased. So these are the units themselves. The black one is called the open PCD. The white one is the open PIC. We're going to get more into it as we go. But this is open source hardware. And one thing for me that I really get into the whole open source hardware thing, I hear a lot of people kind of knock the idea of open source hardware as far as that, well, you know, it's not like software. We can't just download it and go. But there's a lot of options with the Gerber file. Oh, power of Satan compels you. Sorry. Need a young priest and an old priest. But yeah, open hardware I feel is very important just because we have the potential now with the technology. We have Gerber files to where somebody can put up the schematics and everything that you need. You can send these off to a company and pretty much make your own hardware. So going on, here's some of the things that we're going to cover today in our presentation. We've got the information layers, protocol, information on the open PCD and the open PIC, and which are high frequency, and then we have some talk on the ultra high frequency. But first, a little story.
I wanted to tell you guys how I actually came to have these things because it's an incredibly cool story. When we decided we wanted to do an RFID talk again this year, we wanted to work with some different stuff than we did last year to make sure it was different. And so I was searching around online for different pieces of hardware that I could get at a reasonable price that was going to be able to do what I wanted it to do. So I came across this website, openpcd.org, and I was looking at their stuff, and they have these two units that I have right here. And they're open source, and they're designed by two guys from Germany. They're actually members of the Chaos Computer Club. They are also the lead developers on the OpenMoko project. I'm sure you guys have all heard of that. Their names are Miloš Mariak and Harold Welt or Harold something like that. But everything on their site, I mean, it was in English, but like I think I read wrong somewhere, but I thought that they only shipped to Germany. So I emailed them and I said, hey, would you guys be willing to ship to the U.S.? You know, I told him who I was, what we were planning on doing, and he emailed me back and said, I would be more than happy to send stuff to the U.S. As a matter of fact, I'll just send you something for free as an intercontinental hacker diplomacy act. Seriously, that's what he said. So he sent me this unit totally free with everything with it, and then within a few months we had figured out the PCD, which is the reader part, but they had this other unit which is like the brother of the PCD, and we also wanted to get into that as well. But these, I mean, there's only like 8 or 10 of these in the world. Okay, I mean, the development on these things is there's barely anything. It's very, very new, and he sent me one of those for free too. So I mean, these guys are incredibly cool, and the project is incredibly cool, and we wanted to make sure that we were able to represent them and what they did, because it was just amazing to me. It blew my mind when I got the email back. I called him. It was like 12:30 at night, and I was like, dude. So
little schoolgirl excited.
Yeah, I mean, like jumping on my front porch excited. It was amazing. So we wanted people to get interested in this project and get interested in what it does, because the capability for what's there is huge, because everything is completely open source. The firmware, all the hardware, all the software, everything, the stack that goes on the box, everything is completely open. And there's just not enough people working with it. There's not enough people, so there's not enough progress. And obviously, since the guys that do this are doing the Open MoCo thing, they don't really have a whole lot of time to devote, because they're working really hardcore on that stuff. So that's my little story I wanted to share with everybody. So let's get into the RFID goodness. The first thing I got on here, I just wanted to, a lot of the slides that we have are going to be very daunting. We're not going to go over them all. It's there for reference material. This PDF is available on our website. And we wanted it there so if you guys were interested in looking at it later. But I wanted to make sure I covered things that you would see later on in the presentation when I'm talking about the actual devices. And I didn't want you to be confused or lost at that point. So I brought up encryption, and here's a couple of the current encryption schemes, or the current proprietary encryption schemes that are out there for the high frequency 13.56 RFID frequency, which is what's used on most proximity cards. So the top one is the only one we're really all that interested in today, and that's the MyFair standard. It's a proprietary standard from Philips. It's built on another standard that I'll get into in a little bit. And they are the most widely used proprietary standard in the world. Most transit systems, any RFID authentication systems across overseas in Europe and in Asia run generally this frequency. And these devices are designed to interact with MyFair. So that's why I wanted to bring that up. We also got the layers in here, and I'm not going to cover it very much. It's an OSI stack. It's just like your network layers. It's a little different. There's a good website you can go and look for what each individual layer actually does. But during the demo, you're going to see layer 2, layer 3 scanning across the screen. And I just wanted to cover what those were, the transport, or the network layer, and the data link layer. So another thing I wanted to throw in here, because a lot of people don't really, they hear RFID and they think RFID is some different, weird technology, and it's not. It's just RF, it's radio frequency. It operates like a radio does. So you can see what commonality it's got with the different frequencies and all that stuff. So we're going to actually start talking about the units. So I'm going to turn it over to Mr. Morgellon, and he's going to tell you about the hardware a little bit.
And I'm going to try to do this where you guys can hear me. All right, what we have here is a good, nice close-up picture of, this is the Open PCD. This is open source. If you want to right now, you can go download the firmware, the schematics, everything. There's nothing stopping you from getting this, and when you get home and working with it, if you want to. But it's basically a lot of simple components. The only big components you've got on here is you've got a crystal oscillator, you've got a 13.56, you've got an 18.42 oscillator, you've got an you've got an ARM7 processor chip, which is your microcontroller, and then this chip right here, this IC, it's the custom RC632 chip, which is made by Philips, and this is basically the workhorse of the PCD, other than the microcontroller. So this is what's going to do all the decoding of the tag and encoding and process all that and hand it back and forth. So what we have here, we have a picture of the schematic, and this is a close-up. We got a couple little clips so it'll show up better. But what you see here is the antenna, and basically you've got let's see, here we've got inputs coming in from the processor. You've got TX1 and TX2, which carry the carrier signal out to the antenna and energize the antenna. And then it waits for a tag to come into proximity. And when that tag comes into proximity, that tag's got a little coil around it. And the magnetic field from the antenna energizes the magnetic field on the tag, and it powers the chip. And then the magnetic field that's now powered in the tag interacts with the antenna. The antenna picks up that information, and it sends it back to the chip through RX1, or RX, I'm sorry. And then here's how they've got the the RC632 hooked up on their board. And you can see all the pins that they're using. Well, we got a little close-up right here. Up here, this is the oscillator, the 13.56. This is IRQ, so we're just going to use to send the interrupts to the microcontroller to say, hey, I've got some new tag information, stuff like that. And basically, there's kind of a lot going on if you're not a hardware guy. Real fast, is there, raise of hands, hardware people, software people, just curious people? Okay, all right, cool. So I don't want to delve too deep into the hardware stuff. I don't want to bore people. But if you guys are interested more in the hardware and what's going on, I'll be here, so feel free to ask me questions. But here's a more simpler diagram of what's going on with the RC632. So if you just wanted the simplest way to kind of hook it up, here's a nice visual representation of it. We've got over here to our left is just the microcontroller. We've got our in and outs. Here's voltage. The chip uses 3 voltages. We've got an antenna coming out, and we've got our grounds and our oscillator. So really, to set it up in its most basic form, there's not a whole lot to worry about there other than getting the firmware on your microcontroller. So here's a nice close-up of the RC632 itself. You can see here's a layout of all the pins. Just real brief, the TVDD, the AVDD, and DVD are your 3 voltage inputs, and then the AVSS, any of the SSs are your ground. These that are bolded right here, they're all controlled by the TVDD input voltage, and so you see you've got TX1 and TX2, which is your input for the antenna. And this is significant because if you were going to use an external antenna, it had obviously have to be an external powered antenna, but then you would take the voltage off this and then use your powered antenna voltage because you get a much better use. That's why you're using it, and then still send the data back in through RX. So when we see down here at the bottom, we've got a D0 through D7 and A0, A2. This is basically how you address the chip. So when you send your commands to and from the microcontroller, your A is sending the bits for the address, and then the D bits are sending the commands for that address. And then what we've got right here is this is the BOM, or, well, not the word you use at the HackerCon. This is the bill of materials. And as you can see right here, you can download it from the openpcd.org website. And it's got the complete list of every component that you need to build this little bad boy. And there's not a lot there, and I think around the US we're talking maybe $80. But conveniently, it's got all the DigiKey part numbers up here at the top. So you really don't have to look anything up as long as you want to order from DigiKey. I've used DigiKey. I'm happy with them. I've got a nice big fat catalog full of plenty of good stuff there. So I had that in just a second. I'm going there. All right. So here's your part list. So it's page and a half. Not a lot of stuff. Maybe $80 tops. And your first, like say you were just ordering one. A lot of these stuff like the basic resistors and capacitors, you can't order just one up. So you have to order like a minimum of 10 or 15. So the first time you order, it's going to be a little bit more than, you know, if you order a second time or we're building multiple units. So, but where do you get these wonderful toys? How do you use your slides? But basically, you can order these units fully assembled directly from the OpenPCD guys at shop.openpcd.org. So they're fully assembled. I think they're...
I want to make one note with that. If you go to the shop, sign up because you can become a member. Sign up and the prices will change on the units.
Yeah.
When you look at them, they'll be more expensive than they would when you actually purchase them. And you have to sign up to purchase, so just sign up and you can see the actual prices of everything.
Okay, so but you can order directly from them. You can get a fully assembled unit, or you can get just a blank PCB that's already been made if you're really into surface mount and want to surface mount these components. If you want to go totally from scratch, there are companies out there that you can send off the Gerber file. And a Gerber file, for anybody who doesn't know, is basically just a CAD drawing of the PCB board. And so basically you can send this off to the company, and the Gerber file contains all the coordinates. So they put this in basically into a machine, and the machine will lay it all out, and then the machine knows the coordinates to lay your components. So it kind of takes out the human error of shaky hands and bad solder, because they're using wave solder, and it's nice and simple. And there you go. So it's a good way to do it. There's a company that's their website's AAPCB. I've not used them. I can't recommend them. But one of the cool things, and why we are mentioning them, is you can send them the Gerber files and the parts list from DigiKey, and they do it all and just send it back to you. So that's kind of cool. But one thing, if you guys are in the homebrew and people are like, well, here's all these options, why should I homebrew? One thing that I'm a student for electrical engineering right now, and one thing our teacher has brought up that the ROS standards right now, we're using lead-free. There's issues with the tin silver solder, and you get the like whisker growths and little gaps, and you get into reliability issues. So your electronics isn't as sturdy, say, to a drop or long-term usage. And the main thing that really got me behind this is that the military still uses lead, and because lives are on the line, there's no taking chances. So if it's not good enough for the military, then it's not good enough for me. So that's kind of one reason to set out a space in your garage or something and learn to surface mount and get good quality stuff. So, but onto that, we're going to talk about the firmware and actually how, once you've got the unit built, what do you do with it.
So the frequency that we're talking about right now, like I said earlier, is a high frequency. It's the frequency commonly used for proximity cards, the U.S. passports. Actually, all RFID-enabled passports globally use the same frequency, and the RFID-enabled credit cards also use this frequency. So the two main standards that we're concerned about today, because our device reads them, is the ISO 144. Did I miss a 4? Anyway, that number, and then the ISO 15693 standard. The first one is the one used by the passports and the credit cards, and I have a list of the credit cards: the PayPass from MasterCard, the Express Pay from American Express, and the PayWave from Visa. They all use this frequency. If you go into any of the stores or convenience stores, or even some fast food restaurants have them, the little kiosk-looking thing where you tap your card and that's how you pay. That's basically one of these. The technical term is a PCD, and that's why it's called the Open PCD. So that reads that, and then the other standard is used. It's not widely used in the U.S., but it's used a lot overseas, and it's for proximity cards, and those are different than the cards that I have, because they're actually for a longer distance, a longer read distance. So they're designed to travel farther. And now there's a couple. No, that's completely different. I'm going to talk about that later. Okay. So as I mentioned MyFair at the beginning of the talk, MyFair is built on this open standard, and like I said, it's proprietary from Philips. The RC632 chip is made by Philips. It's a reader IC. Basically what MyFair means, what the proprietariness of MyFair is that you can't read a MyFair card without a MyFair reader. So it doesn't have anything to do with the actual encryption of data on the card. It has to do with the encryption of transmission of communication between the card and another device. So if you had a reader that was 14443 standard reader, it's not necessarily able to read MyFair, even though MyFair is built on it, because you have to have a MyFair reader. So, and like I said earlier, that's what a lot of people use, especially overseas. The MyFair card comes in two flavors, or three flavors really. We're going to talk about two. The first one is the classic flavor, and this one actually has keys in it, encryption keys in it for the communication. I'm going to show a bit layout of the way the tag's designed in a little bit. You can get them in 1 or 4K memory, so you can put a lot of information on the card, and it's all open. You can put whatever it is that you want on there. And the way the anti-collision is handled, because we had a question last year on what happens when you put multiple cards in front of the same reader. How does it pick the right one and stuff like that? The anti-collision is handled with that session key. So when it gets a read, it initializes the session key with what's called a UID at authentication time, and then it uses that to communicate. When it knows it's done communicating with that device, it drops that key and goes on to the next one. And then the next one is the ultralight standard, and that, like the name suggests, it's bare minimum. It doesn't have any encryption. It's totally open. It's still MyFair, so you still can't read it without a MyFair reader, but there's not as much storage, and the anti-collision is handled almost the same way, except for it's not encrypted. So here's the ultralight layout of the card, and this is, you can see how it's laid out. The UID stuff is that's the anti-collision. You'll see the 2 lock bits. Those are to lock the card so you can't rewrite them. A lot of times when you write the card, you flip those lock bits and then you can't rewrite them. So, and then you can see the user area where your data actually goes. And then this is the MyFair Classic, and it's laid out a bit the same way. The top block, that's the same stuff, the UID stuff and the block bits and all that stuff is there. Then you have your user block, and then you have your 2 keys and the bits to know what sector you're reading, because you can see it's broken down into sectors, and it's either 16 or 18 sectors. I meant to check that before I did this, but I forgot. But it's either 16 or 18 sectors that are broken up like this throughout the card. So now that you know what the devices can actually read, how do you read them? Well, first you have to put firmware on the device, on the reader. There's 6 different types of firmware that's available currently right now. None of them are really robust. Each one of them has a little bit of an example on how to do 1 or 2 features from the car or from the chip. So you can basically piece things together and come up with a more robust firmware. The one that ships stock is the main dumb reader firmware, and basically all that does is it uses the libRFID stack, which I'll talk about in a little bit, and all it does is read and write tags. That's all it does. So then there's a few other ones. The next 2 show how to mess with the pulse width modulation, so you don't actually have to read a MyFair card with a MyFair reader. You can read any standards as long as you know the modulation scheme. So it shows you how to mess with that. And the Rec A one is an autonomous one. You don't actually need it to be hooked to a computer to do what it does. You just give it power. And the analog and the libRFID are stacks, or the bottom 3 actually have the complete RFID stack in the firmware, so you can write your software directly on your firmware and also have an autonomous device. So we'll talk about the main dumb reader a little bit. Like I said, all it does is read and write. And there's some experimental support for signal interrupts and things like that are on there that you can look at to write your own firmware. Here's a little bit more information about a couple of the other ones that are documented in the wiki, because there's very little documentation about this stuff. I actually have like 63 pages of printed off Gmail back and forth with the developers learning all this stuff because it just isn't there. So I put some more information in there so you can look at that, because that's the other interesting one, the Rec A, because that's the one that's actually autonomous. It actually does what it's supposed to. So like I was saying earlier, it uses the libRFID stack, and what that is it's a open source library for Linux for RFID. It was designed in mind for the Open MRTD project, which is the machine readable travel document, which is the technical term for the passports. And that's why they designed it initially, was so they could have something in Linux to be able to read these devices without having to use somebody else's proprietary software. So they designed that libRFID, and then the PCD was kind of the brainchild of that because they needed the device to actually read it. It's not, they're connected, and they're actually done by the same people, but they're not the same project. It's a totally different project. But a lot of the newer distros actually come with it already. I don't have a list, I don't know, but I do know that a couple of the main distros do come with libRFID pre-installed, when you install the OS. So if you don't have it installed, you just go download it from their website. It's as simple to install. So that has all the software host tools to run the main dumb reader firmware on the board. So this is what's actually giving you the ability to read and write tags with the device in its current state. The main tool is the librfid tool. The librfid-tool is the software's name. And you pass it the variables to make it do different things. If you pass it a -s, a lowercase s, it'll scan for, like, if you have a card but you don't know what it is exactly, you don't know if it's the right frequency or if it's the right standard or if it's MyFair, you know, which version or whatever, you can put that on and do the -s, and it'll actually tell you what it is that you're trying to read. And then you do a -p and you pass it the protocol name that coincides with what you got on the -s, and it'll actually read the data off the cards. If you do a capital S, it'll do a continuous scan. It'll just scan over and over again until you make it quit. And we're going to have a live demo of all this stuff working too. So this is what it looks like when it actually does the read. That last screenshot was the scan part. This is the actual read of a MyFair Classic card, one of the ones I have up here. So, and I'll show you all that. I mean, you can see it's just text. So now we'll talk about the other device a little bit, and I'll pass it back over to Morgellon so he can tell you about the hardware.
All right. The OpenPIC unit is still in development. It's somewhat functional, but there's still a lot more going to it. But there's a lot of room for a lot of interesting things to happen there. But as far as how this unit's working on the hardware level is pretty simple. The OpenPIC does not have an RC632 chip because it's not doing any of the decoding or anything. The only thing I wanted to mention too is the spec sheet for the RC632 is huge. It's like 160 some pages, but it's got all the commands for, you know, how do I use that chip? Well, it's all in here. So. But anyway, so basically, on our PIC, we've got an ARM7 processor, we've got a crystal oscillator, and then the rest are pretty much just simple ICs, logic gates, stuff that's basically, if you wanted to say automated, where if I get this, then I do this, and then basically the ARM's telling it where it's to send the information and what it should do with it. So, and we've got some highlights here from the schematic. And you can see over here on this left side, I mean, it's basically just a bunch of gates. This one down here at the bottom is just a NOT gate. So if it gets a 1 in, it outputs a 0, or vice versa. So it's. And then here we have the bill of materials for the OpenPIC, and it's actually, ironically, it's a little bit bigger than the OpenPCD. But same thing as with the OpenPCD is that you can do all this, got all the Gerber files and everything you need to make it from the openpcd.org website. So there's a lot of room and a lot of possibilities for this thing. So if it's something that you guys wanted to get into or whatever, there's definitely a place for it on that.
So the OpenPIC is actually probably the unit that'll be the most fascinating to all of you, since you are hackers. The OpenPIC is designed to be an RFID card emulator. What that means is you pass it RFID data and it acts like it's that card. So you steal the data from another card and you can give it to this, and this will fool any reader into thinking that it's this tag. You can change things on it, you can mess with the data, you can, not only can you do that, but you can also sniff live data, which it currently does right now. The emulation part of it is not yet implemented because they have to put the anti-collision logic in there. So when it's near a reader and the reader has another card to read, it knows how to handle those different, the Rec A and the other one, the other packet. So this is designed to replace the RFID dump project, which we referenced last year in our talk. The guys that designed these were the guys that did the presentation at the Chaos Computer Congress or Communication, whatever the hell it's called.
Communications Camp. And one thing they did, to interrupt real fast, they since they developed the RFID reader and writer and they're doing all this stuff, all the badges there they had were what they're called Open Beacon. And basically there was a combination hybrid of RFID and Wi-Fi. So they had active tracking Big Brother. You know, they had, if you can find it, there's a little video that shows, you know, a little screen of the area and little red dots of everybody moving. And but the cool thing about it, they gave you the option to turn it on, turn it off to know when it was transmitting, and the option so you could see the data. There were no secrets, but it was an interesting way to do it.
And you can get those too, the Open Beacon stuff. You can get those from the same store, and they're actually cheaper. You can get a little USB reader for like $35 or something like that. And then the tags, the actual Sputnik tags, they made them Sputnik, the actual tags from the camping. You can play around with those, and those are totally open source as well. So that's just another bit of information for you. So here's some screenshots of the OpenPIC in action. Now it takes a little bit more to use the OpenPIC because it's not fully developed. So you actually have to run through it. There's debug, there's analog pins on each one of the units, and you can plug in this debug cord, which goes to USB, and get into it through a terminal, and send it commands and things like that to set the firmware in the correct mode. So you have to do that because it's not smart enough yet to do that. So you have to set it in a mode. You have to set the clock speed down to as low as you can to make sure you get the data right. And then so the top left-hand one, this one right here, this is the OpenPCD actually operating, and this is the terminal with the commands that I sent to the PIC. And then this right here is what you see when the OpenPIC has actually captured data, sniffed data. And then this next slide is the data that you actually sniffed. Now you can't do a whole lot with it in this mode. If you were to just open it up like in VI or something, you'll get a bunch of crazy, weird-looking characters. I can't remember the command. I went on IRC and dude told me how to do it to get it so it looked like this, but I don't remember how to do it. But you're going to see it in the really messed up way when I show the demo. So, and then there's a program that they wrote, a debug or a decode program that'll take that data and it'll decode it into something that you can actually work with. Now, if you go out to the Chaos Computer Communication Camp from this year, they did a talk that's similar to ours, very similar to ours, and they actually talk about what you can do with this data. I didn't have time to play with it at all with the PIC stuff because I just got like this unit like, I don't know, a month ago, maybe less than that, so I haven't had it for very long. So you can go on there and you can see what you can actually do with this. You can analyze it and it tells you certain things that you can look for and stuff like that. So,
when we get ready to talk about this ultra high frequency stuff, I've got some ultra high frequency tags that I was kind enough to have given to me, and what I'd like to do is share these with everybody and pass them around. So wipe off your fingers, no sticky fingers, and at least let everybody see them before they get sticky. But I'm going to walk around and pass these around so everybody can look about and while he's talking.
Okay. The unit that's on the screen right now, it's a unit that I actually got for work because I developed an RFID tracking system at work for our shipping stuff to comply with Walmart because we're a Walmart vendor. So we had to comply with Walmart. So like, as far as work goes, since Nauticon this year until about the end of August at work, my life was like in this stuff, and I did not want to not share this stuff with you because there's more of a chance, unless you work somewhere that's got access control, RFID access control, or if you have a passport or whatever, that's how you're going to see this frequency. But the one you're actually really going to see, like everybody's going to see it, no matter whether they know they're going to see it or not, is this UHF stuff, this Gen 2 EPC stuff. This is the stuff that's going to be on your items when you buy them. So I wanted to make sure I was going to have a chance to tell everybody what it is they're going to be seeing if you go to the store and you notice, you go to Sam's or whatever and you pick up a case of something and there's an RFID tag on there. And how you can get it. Now I actually forgot the unit at home, and that's okay because I wasn't going to do a demo of it anyway. But this is the firmware, or not the firmware, but the software and the DLL for this is completely open source as well. So it fit kind of right in with the theme of things. So it's made by WJ Electronics. It comes with a demo application that shows you everything that you can do with this device and everything that you can do with UHF Gen 2 stuff in general. So this is just show you when you boot it up, you got to give it your COM port for the card, and then You can fire it up, and then this shows some tags being read. And you can see on the left-hand side of the screen there's a key, and it tells you what generation of tag you're reading. And you can see on the read that they're orange, which matches the Gen 2 stuff from the screen. And you can see the data going across the bottom of that. Now, like I said, the UHF is the one that's going to be most widely used. I mean, the most manufactured RFID tags are UHF, EPC, Gen 2 tags. That's just the way it is. That's what Walmart said they wanted to use. That's what the Department of Defense said they wanted to use, so that's what we're using. But another thing is UHF is what is used in the highway toll systems. I didn't cover a lot of that. In here I have a list at the very end that shows the name of every toll system and what state they're in and what toll systems they cooperate with. Like you can have a unit from Jersey and be driving in, I think, Virginia, and it'll work because they're compatible with each other. If you want more information on that, I suggest you go download BinRev 199, the radio show, and they talk about that in length, and it's very, very interesting. That's where I learned like everything I know about the toll systems is from that episode. It's binrev.com/radio, I think, in episode 199. So I keep saying EPC Gen 2. I mentioned Gen 2 last year. We were totally confused about what Gen 2 was last year. I mean, I shit you not. We were so mad. We gave you such wrong information. It wasn't even funny. So I wanted to make sure that we recovered from that. So this is what I've been using at work. So Gen 2 comes in 7 different standards, and they're broken apart by the type of item being tagged. And the two that are only really relevant to most people are the SSCC and the GTIN, or the SGTIN, the serialized GTIN. But if you work, as a military vendor, or you're in the military or whatever, you'll see the DoD construct as well. The EPC is broken up into sections, so you got your set of bits or whatever, and it's broken up into sections, and that determines what it is that you're actually reading. And every EPC has a common header, and that's what tells the hardware or the software, depending on how it's being handled. That's what tells it what it's looking at. So, in general, like all UHF tags are the same. There's not a tag for one of these and another tag for another. They're all the same. So it's just a matter of how you code them, and that defines what it is. So here's the coding schemes for the SGTIN and the SSCC, and in the top one it shows you how the bits are broken down. So there's 96 bits in the UHF RFID tag. That's the most common is 96-bit tag. So it shows you how that's all broken down based on the header values and filters, and I'll go into that in just a second. So here's actually EPC broken down, so you can actually read what it is. Because when you get the tag and you read the tag, it's not the information that's on the tag. You have to bust it up, decode it, and then you'll know what you're looking at. So the top one is actually like if you were to read a tag that you're getting on your junk at Walmart, that's what you're going to see when it comes out from your reader device. So the next one shows the actual data that's on the tag, and I'll show you how I got that. I knew that because I put the data on the tag, but I'll show you how that breaks down if you reverse it. So you convert it into binary. You convert that into binary, and you get this big string. So you can break it down. The first 8 bits of it is always the header value. That always tells you what header value you're looking for. The headers are defined just about everywhere. I mean, you can find them online, but I also have them in this slideshow. So if you want to look, you can figure out what header you're supposed to be looking at. 48 is the one you're going to see on item level stuff, because that's the SGs, and that's what you're going to see. So the next one is the filter value, and that defines what type of tag it is or what type of item it is. Like 0 is for single items, and then 1 is for case items, and then 2 is big items that only fit on one pallet, so like a bike or a grill or something like that. And then the partition tells you how it's broken up. See, it's broken up into a company prefix and an item reference, and this number can be variable. The partition lets you know how many bits goes from one side to the other, so it can be anywhere between, I thought I had something, yeah. See, the company prefix can be from 20 bits to 40 bits or 24 to 4 for the item reference, and the partition tells you how that's broken down. So once you figure out how to break it down, you break it down. The first number is your company prefix. That's what's going to be like if you're buying something from, I don't know, Sony, for instance, or something. Every Sony product's going to have the Sony company prefix, so you're going to know it's from Sony. The next thing is the item reference, and that's going to be unique per item. So you got, every one model of this DVD player is going to be, the same item reference, but the next, the Blu-ray player is going to be a different item reference. And then the last number is the serial number. That's the largest bit of data that's on the tag, and that's the unique number, that globally unique is what they're trying to be. It'll always be unique. So you combine all those numbers, and that gives you a unique tag and the data you can use with it. Now you can use the serial, like you could read this data, pump it back into your system. You can change things around, your company prefix, your item number, depending on how they end up handling the data, and be able to modify it in a way to do whatever it is that you want to do. But the problem is that they're not using it yet. So here's the documentation on the partition, the filter, and the header and stuff. I'm not going to go over it. But here's the ICS, which stands for, now I can't even remember the damn acronym. So this is all the stuff for the toll systems. So here's that list, and like I said, go read BinRev 190, or go listen to BinRev 199, and you'll get a whole bunch more information about that. Here's some links to all our sources for the data, and it's brought to you by openpcd.org project, so go out there and check out their stuff, and of course the Infonomicon Computer Club. So,
try to do a demo first? Yep, let's do the demo. All right, so we're going to try to do a live demo real fast, because he got to rambling, because I walked away and didn't keep him in line. So
happens every time. Well, luckily I got everything set up so I can show you real fast. Okay, we're going to do, I'll show you first the reading an actual tag with the OpenPCD. So I'll set the tag on the reader, and then in this top left-hand terminal is where I'm going to be at. So I'll do the -S first so you can see. And you see, right there it says it's a MyFair Classic card, so I know what I'm trying to read. So the next thing I'll do is do a -P, MyFair Classic, and there we go. There's your card data. You also have in this, all this software comes with the libRFID stack, and you also have a MyFair tool, which operates similarly, but it's for MyFair stuff only, and you can read specific sectors with this. You can also write. I'm not going to try to write it because I got it wrong last time, but you can write MyFair sectors with this as well. So we'll jump into the pick now real quick, and the first thing we have to do is we have to set the clock speed down. So you actually have to hit shift right brace or right bracket to get it down. So you just look. I think I might already hit it. Sometimes it doesn't go down. There we go. Okay, I got it. So this right here, this number right here, that's your clock speed. So we got to get that down. Then we hit B to get the SSC mode to 5. Okay, and that gets it ready for reading. So when we hit S to start capture, go over here, run the OpenPick test program. Let that run, and we'll run the libRFID tool. There you go. So we just sniff that data. Now if I showed you the decoder data, I suppose I can open it up. It automatically throws the data in temp, and it's called OPCD_samples. So there's your coded data, encoded data. And then when you do the decode, it doesn't spit it out, so you have to pipe it to a file or whatever. But you already saw that data. And this is the same thing because I've got the same card. The screenshot's really good. So if you want to look at more of it, go ahead and go onto the website infonomicon.org/PN11. We'll have the slide, the PowerPoint, and also the PDF of the PowerPoint up there as well. So you can check that out. One thing I wanted to mention before we wrapped up is if you guys are interested, if I've got you all hyped up about this stuff and you are into hardware or whatever, I have the blank PCBs. They sent me these from Germany. They're $20 for the PIC, $25 for the PCD. So you can get it right now. What? Infonomicon.org/PN11. So if anybody's interested in these, find me and we'll talk. But I think that's all of our time, isn't it? Can we do questions? Do we have any time for questions?
Really good questions.
Okay. By the mystik you said was encrypted, you were just able to snip it. Is it unencrypted once it does?
Okay. I should probably elaborate just a little bit on that. It's not actually sniffing the tag data. It's sniffing the reader data. So you're getting the reader information, the information that the reader's sending to the card to do the authentication and to bring the data back, because it sends out information. So that's what you're getting. That's what you're sniffing with the PIC, is the reader data, the reader to tag transaction data.
You're not actually getting the data that's on the tags?
No.
Okay. The other question is the Gen 2 stuff, is it encrypted?
No.
Gen 2 stuff. So if I have a bag full of Walmart stuff, let's say we have...
Yeah, I can just walk by and read it.
vibrators and synthesizing gel. You walk past, someone can see if you have a sniffer that's still carrying a bag full with product.
Yeah. Yeah. Totally unencrypted.
This stuff, right?
Yeah.
Mm-hmm.
So if it's into medicine, isn't that kind of a HIPAA violation of sorts?
I don't think so, because you can't. In those situations, those things are locked down really hardcore. When you write to those tags, you flip the lock bit off and it's done. You can't rewrite to it. I mean, you can just. Well, no, because it's public information. It's not like the person. It's just what's there. It's the item number for that pill or whatever, and then it's the person or the company that manufactured it. Exactly. Yeah, it's not. Okay. Any other questions? Okay. Yeah, you got to be closer than that. You can put, this has got an antenna in it, but you can wire up an external antenna, but you got to amplify the signal and then bring it back down to bring it back. So, I mean, if you were to just wire up a normal antenna, it would just give you a wider range, but your range is still like this. It's got to be between the readers, so you're still really close to it.
Yeah, because it's using the principle of induction. Like, you could make a hula hoop size loop, and it's just, you've only increased the relay by that range. It's not any further out. So you've actually got to power it, and then there's crazy formulas. That's one thing I wanted to talk about, but there's a whole lot of different formulas and a lot of different ways to make your antenna, whether it's coiled, whether it's a loop, whether it's square, what's going on, and you've all got to take into the account like the wire gauge, the impedance of the wire, the size, and there's, it's a big fat equation
Crazy
that makes my head
equation.
hurt.
Yes.
So,
Crazy equation. Yeah, or
Really
walk
close.
past somebody that's got it on their person. There's one called what? Oh.
Yeah, or get a little drone and just hover around Walmart.
Not at all. So.
Yes, sir.
I wanted to look into that, but I didn't have time.
Yeah, the Prius.
It's one of these two. It's one of these two. I guarantee you, it's either UHF or it's the high frequency. I guarantee. I just don't know. Yeah. Try 925. 925. That's the ultra high frequency. Try that and see if you'll get anything with that. I'd be curious to know if you.
925 to 928 megahertz.
Yeah. Nice. I haven't heard of that. Cool.
So, yeah, well, you can build your own unit and replace it yourself for cheaper than what you'd have to go. And that's a good point. A lot of the key modern car manufacturers are moving to something. Unlike the Kias, they don't have it in the car, but they've actually got a little thing down underneath the dashboard, and you've got a card, and you have to tap your card up underneath the dashboard of the Kia before it'll start. So, you know, this is something we're going to see more and more of. So might as well get used to it and get some tools to work with it.
Yeah. Any more questions? No, these ones won't. One frequency only. Okay, we're out of time. So thanks everybody
guys.
for coming.